This is electricity example problems number 8, 9, 10, and 11, and all of these have to do with circuits. In this very first example, you see that we have just part of a circuit. We just have 3 resistors, and they are lined up right next to each other. The first one's 12 ohms, the second one is 4 ohms, and the third one is 6 ohms. And they want us to find out if they're connected in series, which means it looks like a train, so just one right after the other. They want to know what is the total resistance. The total resistance in series is always equal to the first resistor plus the second resistor plus the third resistor. So in our case, we're just going to take 12 ohms plus 4 ohms plus 6 ohms and add them together. And when you get those all together, you should end up with 22 ohms. And that is example number 8. In example number 9, it says find the total resistance of the same 3 resistors now connected in parallel. This one's a little bit more difficult because we don't just add the 3 together. Instead, we use a different equation, and the equation we're going to use here is 1 over the total resistance will be equal to 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor. Let's go ahead and do that. So we have 1 over the total should be equal to 1 over 12 plus 1 over 4 plus 1 over 6. Now sometimes in the problems you can just go ahead and divide the numbers, add them up, and then take the inverse. But in this one, because we have a simple common denominator, let's just change everything to 12 on the bottom for our denominator. So that'd be 112 plus 312, 3 over 12, plus 2 over 12. Let's go ahead and add all that up, and if I add it, I end up with 3 plus 2 is 5 plus 1 is 6 over 12. But be careful, our resistance in this parallel branch is not 1/2. We have 1 over RT is equal to 6 over 12. So now we need to flip both sides. RT over 1 will be equal to 12 over 6, which means that my total resistance in this branch is 2 ohms. The important thing to worry or to know about these parallel resistors is the total resistance cannot be any bigger than the smallest resistor. So we do have 2 ohms, and that is smaller than the 6 or the 4. And the 4 is the one that we need to worry about. In the previous example, you'll remember that we added the 3 together. And so for this one, your total resistance of 22 ohms needs to be bigger than your biggest resistor, which it is by far. And so that makes that one a little bit easier. Let's go on to a little bit more difficult problem. Now we actually have a full circuit where we have a battery on the inside, and it says find the total current passing through the circuit. To do this one, we need to do several steps. I'm going to move the picture over to the side, and the first thing that we need to do is let's find out what the total parallel resistance is just in this branch. So we need to find the parallel resistance. So we're going to call it RP, and remember that would be 1 over RP is equal to 1 over the first resistor plus 1 over the second resistor. Our first resistor is 12, so we're going to do 1 over 12 plus 1 over 6. We need a common denominator, so we have 1 over 12 plus 2 over 12s, which gives me 3 over 12. But remember, that is 1 over the parallel resistance. So our parallel resistance should be equal to 12 over 3, which is really equal to 4 ohms. So this part right here is actually equal to 4 ohms. That whole thing is. Because I have another resistor right next to it and it's in series, the total resistance in this circuit will be equal to the first resistor plus the combination of the two in this part, in the parallel part. So we'll take the resistor in series plus that total resistance in parallel that we just found. So that will be 4 plus 4, and we end up with a total resistance in the circuit of 8 ohms. Now we can find out how much current is in the circuit. We know that the voltage is equal to 16 volts. We know that the resistance is 8 ohms. So let's use our equation V is equal to I times R. Our voltage is 16. We don't know what the current is, but we do know that the resistance is 8 ohms. If I solve for I, I'm going to divide both sides by 8, so my I should be equal to 2 amps. That is number 10. We only have one more problem to do, and this is number 11. It says find the current in the 9 ohm resistor. So here is our picture over on the side. They want to know what is the current going through just this one resistor. To do this, we're going to need to go ahead and solve similar to what we did in the last problem, where we need to find out what is the total current in the circuit. Once we've done that, we'll be able to find out what the current is running just through that 9 ohm resistor. So this one actually is a several step problem. The first thing we need to do is let's figure out what is the parallel resistance right here. We know that 1 over the parallel resistance would be equal to 1 over 9 plus 1 over 18. The 9 on the bottom becomes 18. We can put a 2 here, so we end up with 3 over 18. And if I flip both sides, 18 divided by 3 will give us 6 ohms. And so that's what we have in this part right here. So that'll be 6 ohms. If I want to find out the total resistance, I need to take the resistor that we have in series, which is right here. That's the 6 plus the resistance we had in parallel. And we're just going to add the two together, and we end up with 12 total ohms of resistance. We need to now go ahead and figure out what is the total current in the circuit. We know that V is equal to I times R, so let's rearrange the equation. I is equal to V over R. Our voltage is 36 volts, and we know our total resistance is 12. So if I divide the two, I end up with 3 amps. Now we know that in this entire circuit, we have 3 amps of current. But that doesn't tell us what the current is just in this 9 ohm resistor. So let's go through and figure out what is, for this little parallel branch, we need to figure out what is the voltage going through each one of the two resistors. So let's go ahead and clear some of this off. We want to find out what is the voltage going through this branch. To find the voltage going through the branch, we're going to say V is equal to I times R. We know that the voltage then is equal to 3 amps. And then if you remember, the total resistance in this part of the branch was 6 ohms. So we'll multiply that times 6 ohms. And your voltage here is now 18 volts. So there's 18 volts going through this whole thing. If we make this a little bit bigger, we can draw the two resistors. And for each resistor, the 9 ohm and for the 18 ohm resistor, the voltage going through each one of those is equal to 18 volts. So in parallel, each one of the resistors gets the same amount of push. You don't need to add them together, that just actually gets the same push going all the way through. Now we can go ahead and solve for what they wanted us to in the first place, and that is what is the current in the 9 ohm resistor. For that 9 ohm resistor, we know that the voltage is 18 volts, and we know that the resistance is 9 ohms. So let's just simply go back and use our equation again, Ohm's law. I is equal to V over R. Our voltage is 18 volts, and our resistance is 9 ohms. So if I divide the two, I end up with my final answer, which has taken us several steps, and that would be 2 amps.